Questions 1 through 10 on the 2010 Grade 12 AMC 12B. Michaela attended 2 meetings during her 9-hour workday. The first meeting took 45 minutes, and the second meeting took twice as long. What percent of her workday was spent attending meetings? The first meeting was 45 minutes, but we have to convert it to hours since we're comparing with hours. So 45 minutes is 3 over 4 hours. Second meeting was twice as long. So it's not 3 over 4, it's twice that, which is 3 over 2. And then we have to divide by the 9-hour workday. So you add this fraction, you get 3 plus 6 over 4 over 9. And this is therefore 9 over 4, invert and multiply, and you get 1 over 9, and therefore this is 1 over 4. And in terms of a percentage, a quarter is 25%. So number 1, the answer is C. A big L is formed as shown. What is its area? Well, we can chop it like that, and therefore this is 2, this is 5. So this rectangle right here has an area of 2 times 5, which is 10. And then this is, of course, 2. This is no longer 8 because we cut this 2. This is now 6, that distance. So now we have 6 and 2. 6 times 2 is 12. So the area of that big L is this 12 plus this 10, which is 22. Number 2, therefore, the answer is A. A ticket to a school play costs X dollars, where X is a whole number. A group of 9th graders buys tickets costing a total of $48, and a group of 10th graders buys tickets costing a total of $64. How many values for X are possible? So for the 9th graders, I'll just call N representing the number of 9th graders, and they each pay X dollars, and the total is 48. So X is therefore 48 divided by N. For the 10th graders, I'll call that T. They each pay X dollars, and their total is 64. So X is 64 over T. So basically what the question is saying is that for this and this to be equal to a whole number, because X is a whole number, what are the different possible values? All right, well, we have to just look at the fact that 48 is being divided by N and 64 is being divided by T. So X could be obviously equal to 1. It could be 2, 4, 8, and 16. For any of these, you would get integer values for N and T, because N represents the number of 9th graders and T represents the number of 10th graders. So the number of values is what they're asking, and there's 5 of them. So 5 possible values for X. So number 3, the answer is E. A month with 31 days has the same number of Mondays and Wednesdays. How many of the 7 days of the week could be the first day of this month? So we start off with just a basic calendar, and when we do that, we can label the first scenario, which is if there's 5 Mondays and 5 Wednesdays. So this will be 8, 15. You can just add 7 to get the numbers quickly. 30 and 31. As you can see, if you do that, we create a scenario where there's 5 Mondays and 5 Wednesdays. So the number of Mondays and the number of Wednesdays is the same. And the first day of the month in this scenario is a Monday. Now, we want to create another scenario because 1 is not even one of the answer choices. So there's obviously more possibilities for the first day of the month. Now the key in this question is same number. We have 5 and 5 in this first example, and that's the only way to do 5 and 5. But what about 4 and 4? 4 Mondays and 4 Wednesdays. Well, that can happen if you have the following scenario. You have the first of the month as a Friday. And if you do that, you'll get the Monday as the 4th, 11th, 18th, and 25, like that. And just for the sake of completeness, I'll just fill in just a few of these, just so you can see how this works. And then the Wednesdays would be the 6th, 13th, 20th, and the 27th. So now we have a scenario where we have 4 Mondays and 4 Wednesdays. The same number exists for those 2 days. And the first of the month is a Friday. But there's one more scenario that this can hold true, is if you shift everything 1 day going back. So this becomes the first, and this becomes the second, and so on. If you do that, you will also have an equal number of Mondays and Wednesdays. But if you shift one more to put the 1 here, then things get lopsided. Then you get, 5 Wednesdays and only 4 Mondays, and that's not going to fulfill the criteria of the question. So Monday, Thursday, and Friday are the possible choices for the first day of the month. So 3 possible choices. So number 4, the answer is B. Lucky Larry's teacher asked him to substitute numbers for A, B, C, and D, and E in the expression right here, and evaluate the result. Larry ignored the parentheses but added and subtracted correctly and obtained the correct result by coincidence. The numbers Larry substituted for A, B, C, and D were 1, 2, 3, 4. What number did Larry substitute for E? So in this question, they're saying that if you perform this task with the parentheses and without the parentheses, the result will be the same for a certain value of E. And they want you to, of course, figure out what that E is. So let's do it with and without, of course. So when I drop the parentheses, it just becomes like this. So let's figure out both of these using the numbers 1, 2, 3, 4. The first one here, 1 minus 2 minus 3 minus 4 plus E. This becomes 1 minus 9 plus E, and therefore that's negative 8 plus E. And that's about as far as we can go there. This one, if we substitute in the numbers and perform this function, let's see what we get. 1 minus 3 minus 4 minus E, and this is going to be minus 1 minus E, and this is 2 minus minus 1, so 3 plus E, and then finally 1 minus 3, negative 2 minus E. So this, they're saying, is equivalent to that for some value of E. Okay, no problem. We can set those equal to each other and then solve for E. If we do, we get 6 is equal to 2E, and therefore E is 3. So number 5, the answer is D. At the beginning of the school year, 50% of the students in Mr. Wells' class answered yes to the question, "Do you love math?" and 50% answered no. At the end of the school year, 70% answered yes and 30% answered no. Altogether, X percent of the students gave a different answer at the beginning and end of the school year. What is the difference between the maximum and the minimum possible values of X? So I'm just going to say there's 100 students in the class, big class, and just makes it a little bit easier. So we got at the beginning 50-50 for the first part of the question, right? But then later at the end of the school year, it becomes 70-30 for answers of yes and no. Now we have to figure out what are the minimum and maximum with regard to answers changing. Okay, so I think I can do that. The first scenario, of course, I think is when we have nothing changing here. 50 said yes, then 50 say yes again. But in order for this number to become 70, 20 obviously had to come from here. And that's the only way that became 70. If 20 changed, that means 30 did not change. So what they are interested in is what percentage gave a different answer. Well, in this scenario, these guys gave a different answer. So in this scenario, X is equal to 20. Now let's look at another scenario where we're trying to maximize X. I think that can be done if we maximize, obviously, the number of people who change their answer. So I'm going to do extreme case scenarios. So every single one of these 50 changed their answer. And if that is the case, the only way this can be 70 is if 20 say yes. But if 20 say yes, then that means 30 change their answer. So that is extreme case scenario on the other end of the spectrum. Now, how many changed their answer? Well, these 50, they went from no to yes, and these 30, they went from yes to no. So x here is 80. And they want the difference between the minimum and maximum values of x. Well, the maximum value is 80, the minimum is 20, so the difference, which is a subtraction, is 60. So number 6, the answer is D. Shelby drives her scooter at a speed of 30 miles per hour if it is not raining and 20 miles per hour if it is raining. Today she drove in the sun in the morning and in the rain in the evening for a total of 16 miles and 40 minutes. How many minutes did she drive in the rain? So the total distance is 16 miles and the total time is 40, but I'm going to convert that to hours since we are talking in terms of miles per hour. So we have to, of course, use that formula. Speed is equal to distance over time, or any variation of that formula, such as time is equal to distance over speed. And she has 2 times, the time in the sun, the time in the rain, and that totals 2 over 3. And the time in the sun, which I can, of course, call TS and TR to denote time in the sun, time in the rain, is going to be ds over the speed in the sun, and that is 30, according to the question. The time in the rain is the distance in the rain divided by the speed in the rain, which is 20. And this is our equation. But unfortunately, we've got 2 variables. But that's not a problem because ds plus dr, the distance in the sun, the distance in the rain, is equal to 16. That's the total. So I can substitute one for the other. So for ds, I will substitute 16 minus dr. And there we go. We now have one equation and one variable. So now it just becomes just plugging through with this. So let's see here, common denominator, top and bottom. 32 minus 2dr plus 3dr. And then that's 60, so I'm just going to cross multiply. 60 times 2 is 120. 120 divided by 3 is 40. And this is 32 plus dr. So that means dr is equal to 8. But they don't want the distance. They want how many minutes. So they want the time that that she spent in the rain, driving in the rain. Okay, the time in the rain is the distance in the rain divided by the speed in the rain, and that is 20, right? So therefore, it's 8 over 20. And if you multiply top and bottom by 3, you'll get 24 over 60, and that tells you how many minutes. 24 over 60 hours is equivalent to 24 minutes. So number 7, the answer is C. In every high school in the city in Euclid sent a team of 3 students to a math contest. Each participant in the contest received a different score. Andrea's score was the median among all the students, and hers was the highest score on the team. Andrea's teammates Beth and Carla placed 37th and 64th respectively. How many schools are in the city? So we have school number 1, school number 2, school number 3, and so on, all the way until school number N. So there's N schools. Now, each school has 3 students, and the school that Andrea attends has Andrea, Beth, and Carla as the students. And they tell you that Beth placed 37th, and Carla placed 64th, and Andrea placed the highest. So she's obviously somewhere greater than Beth and Carla. So her placing is obviously going to be greater than Beth and Carla. So we don't know where she placed. Now, the key of this question is that her score is the median. Now, there's n schools, and each school has 3 students. So to figure out the median, you would then add 1 and divide by 2. That's how you figure out the median. So, for example, if there was 9 schools, you would multiply by 3, which is 27. And to get the median, the middle student, it would be 27 plus 1 divided by 2, which is 14, right? So this is going to be the median, which is Andrea. That's her score. Now, where do we go from here? Well, one thing I immediately noticed is that n must be a odd number. And if that is the case, then we can immediately eliminate 3 of the answer choices, and that very much helps us. So that means we're down to n being either 23 or n can be 25. Let's see which one of these works. Well, if n is 23, let's calculate what a is. If it's 23, a will be 35, right? 23 times 3, 69 plus 1, 70. 70 divided by 2 is 35. And then if it's 25, that's going to be 76 divided by 2, 38. So this represents a, and this represents a for 23 and 25 respectively. Now you tell me which one of these is legit. Meaning which one of these allows Andrea to have placed highest among her teammates. Well, it's if she placed in the 35th position. Right? Because if she is 38th, then that means Beth beat her, because Beth finished 37th. So A is 35, and therefore N is 23. So the answer to number 8 is B. Let N be the smallest positive integer such that N is divisible by 20. N squared is a perfect cube, and N to the power 3 is a perfect square. What is the number of digits of N? N is divided by 20. It's divisible by 20. So I don't know what N is, but obviously N contains 20. That's the only way it can be divisible. So N is something times 20, and 20 is what? 2 squared times 5. Okay, so far, that's all we know. But if that is the case, then I'm going to be able to make N with powers of 2 and powers of 5. I don't need to introduce any other numbers because they really just want us to figure out the smallest possible N. Okay, I don't know how many powers, so I'm just going to put A and B. So combining this, N is going to look like this. It's going to be 2 to the power of A plus 2 times B to the power, 5 to the power of B plus 1. Okay? So that is what we have to work with. Now let's go to the next part of the question, which is N squared is a perfect cube. Okay? So N squared, so this is my N. This all squared is some perfect cube. All right? And then the next part is that N cubed is a perfect square. So if I take N and then I take the third power, that they're saying is some perfect square. Whatever, p squared. Okay, so now we just have to fiddle around with this. So first let's just do the math here. This is going to be 2a plus 4. And then this is going to be 2b plus 2, correct? And that's m to the power of 3. And similarly, this is 3a plus 6 and times 5, 3b plus 3. And that's p squared. Okay, so we just have to plug and play here now. You know, how is this going to work? Well, if a is 1, for example, does this work? It becomes 6, and that is divisible by 3. Okay, that's good. But what if a is 1 over here? It becomes 9, and 9 is not divisible by 2, right? So that doesn't work. How about a equals 2? And that's all this is now, trying to figure this out. If a is 2, this becomes 8, and 8 is not divisible by 3. So that's out. How about a is 3? This becomes 10. 10 is not divisible by 3. How about if a is 4? If a is 4, this becomes 12. Okay, 12 is divisible by 3. What about here? If a is 4, it's 12 plus 6, and that is 18. 18 is divisible by 2. So a is 4. Great. So that means this is going to be 2 times 4, which is 8. So this is 12. And this is going to be 3 times 4 is 12, so this is 18. Okay, now we got to figure out what is b to make both of these work. Same story, and I'm not going to bore you by going through 1, 2, 3. I already figured this out. It works when b is 5. And I'm sure you can figure that out also. When b is 5, this becomes 12, and this becomes 5 times 3 is 15, 18. So this is indeed a perfect square, and this is indeed a perfect cube. Now, we're not interested in these guys, right? We're interested in just n. Well, this is n. So substitute a equals 4 and b equals 5, and you get 2 to the power of 6 times 5 to the power of 6. And that's it. And that, I hope you can recognize, since the exponents are the same, you can combine the bases, and that just becomes 10 to the power of 6. 10 to the power of 6 is 1 million, and 1 million, just in case you forgot, has 7 digits. So number 9, the answer is E. The average of the numbers 1 to 99 and x is 100x. What is x? So, as always, how do you take the average? You add all the numbers. So we're adding all the numbers until 99 consecutive numbers and x. And of course I have to divide by how many there are, and that's 100 numbers because there's 99 plus 1. And then that they're saying is 100x. So this is the mathematical equation. This part here, I'm sure you can add up with that formula, n times n plus 1 over 2. The sum of consecutive numbers from 1 until n. So that's going to be 99 times 100 over 2 plus x, and this I can cross multiply and get 100 times 100x. This is going to be 99 times 50, and then bring that over and I get 9999x. 9999 factors to 99 times 101. And then therefore, since I've got 99 on both sides, those cancel. And I just get 50 is 101x. And then solving for x, you just get 50 over 101. So number 10, the answer is B.